Hello everyone, today we're going to be learning about how to determine aromaticity for molecules such as our good old pal benzene over here. So in order to do this, you have to go through a 4-point criteria for the molecule to determining whether, number one, is it planar? So are all the atoms in the cyclic molecule on the same flat plane? Number two, is it cyclic? Are all the atoms contained in a ring structure? Number three, is there conjugation? So is there alternating pi bonds? And lastly, number four, does it obey Huckel's rule? So Huckel's rule is the concept that the total number of pi bonds in a molecule, right here, these bold lines, they equal the formula 4n plus 2. Moving on to examples, there's 3 questions here. Feel free to pause the video and do the questions independently and check back for answers. So I like to approach these questions starting at the second criteria, cyclic, and work my way downwards and finish at the planar criteria, which should be determined last. Question 1, is it cyclic? As we can see, there is a ring structure with joined starting and end points, so that is a yes. Is it conjugated? Alternating pi bonds. So double bond, single bond, double bond, single bond, double bond, single bond. Yes, the molecule is conjugated. Does it obey Huckel's rule? So the number of pi electrons are 2 pi electrons per pi bond. So here are the pi bonds here. There is 3 pi bonds and therefore there is 6 pi electrons. Now with Huckel's rule we have to determine n in this formula to match this number, and n is a non-negative integer, so 0 going upwards. If n equaled 1, 4 times 1 equals 4, plus 2 equals 6. Therefore, the formula would be fulfilled, and therefore this molecule obeys Huckel's rule. And as we can see, all 3 criteria have been met, and therefore it is safe to assume that this molecule is planar and therefore aromatic. Question 2. As we can see, the molecule is a ring structure and is therefore cyclic. Is it conjugated? Let's see. Double bonds, single bond, double bond, single bond. Yes, it is conjugated. Does it obey Huckel's rule? So 2 pi bonds equals 4 pi electrons. And the formula for n plus 2 equals 4 pi electrons. And let's try solve for n. If n was 0, 4 times 0 equals 0 plus 2 equals 2. So it is not 0. And any number upwards would just be a higher result. So therefore the n must be a fractional number, which is 0.5, a half. It's worth a half. And that is not a non-positive, a non-negative integer. Therefore, the molecule does not obey Huckel's rule. And since not all the lower 3 criteria were met, you cannot assume that there is planarity. I guess we can put an X there. This molecule is not aromatic. Moving on to question 3. Is the molecule cyclic? Yes, there is a ring structure. Is it conjugated? Let's see. Single bond, double bond, single bond, and back to a single bond. So, no, it is not conjugated. There are no alternating pi bonds. Does it obey Huckel's rule? Let's see. 1 pi bond equals 2 pi electrons. Solving for n. So if n was 0, so 4 times 0 would equal 0. And then plus 2 equals 2. And that matches the number of pi electrons. Therefore, the molecule obeys Huckel's rule. Since the lower three criteria points are not met, you cannot assume that the molecule is planar. So, therefore, this molecule is not aromatic. And I just want to revisit why this molecule didn't meet the conjugation criteria. So, in an aromatic molecule, every atom has to have an overlapping p orbital to continue the continuous cyclic system. As we can see here, this molecule has a pi bond, and then it is it is sp3 hybridized. So therefore, the sp3 hybridization breaks this continuous cycle and therefore makes the molecule not aromatic. I hope this video helped you out, and don't forget to stay cyclic.